Imagine having a voice assistant that's completely private, where your voice requests stay local and don't get sent to the cloud. This is exactly what our product offers. Let's take a look at how it works. Suppose you're in the kitchen and you want to set a timer for 10 minutes. You simply say, "Hey, set a timer for 10 minutes. The assistant quickly responds, "Timer set for 10 minutes. The entire interaction happens locally on your device, without any data being sent to the cloud. The user input in this scenario is your voice command, "Hey, set a timer for 10 minutes. The output is the assistant's response, "Timer set for 10 minutes. The boundary between the user and the system is the microphone and speaker on your device. You speak into the microphone, and the assistant responds through the speaker. This simple interaction is made possible by a complex architecture that involves several components working together seamlessly. At the heart of our product is the speech recognition system, which is powered by OmniVoice-Studio. This repository is responsible for recognizing your voice commands and converting them into text that the system can understand. OmniVoice-Studio is a powerful tool that can recognize speech in multiple languages and can even clone voices, making it an ideal choice for our product. Once the speech is recognized, the text is passed to Onyx, which is our local large language model. Onyx is responsible for understanding the context of the command and generating a response. It's like a brain that can process and respond to natural language inputs. Onyx is a self-hosted platform that can be easily integrated into our product, making it a crucial component of our architecture. The response generated by Onyx is then passed to Payload, which is our productivity component. Payload is responsible for managing the workflow and ensuring that the response is delivered to the user quickly and efficiently. It's like a project manager that oversees the entire process and ensures that everything runs smoothly. The user interface of our product is handled by magicui, which provides a range of pre-built UI components that can be easily customized to fit our needs. Magicui is built using React and Tailwind, making it easy to integrate into our product. Finally, coolify is our DevOps component that ensures that our product is deployed and managed efficiently. Coolify provides a self-hosted alternative to Heroku and Netlify, making it easy to manage our servers and applications. Overall, our product is a complex system that involves several components working together to provide a seamless user experience. With OmniVoice-Studio, Onyx, Payload, magicui, and coolify all working together, we can provide a private and efficient voice assistant that meets the needs of our users. When an inference request fails or the local LLM is unresponsive, the assistant applies a retree policy with graceful fallback to a cached response, preventing hard errors from breaking the user session. As we dive deeper into the architecture, let's trace a voice request through the complete system. When a user speaks to the voice assistant, the audio is captured and sent to OmniVoice-Studio, which uses its speech capabilities to transcribe the audio into text. This text is then passed to Onyx, which acts as the local large language model, to process and understand the intent behind the request. Onyx's advanced capabilities, such as RAG and deep research, enable it to generate a response to the user's query. The response from Onyx is then sent to Payload, which handles the productivity aspects of the system. Payload's Next-Nay's native CMS and admin panel allow it to manage the response and generate the necessary API contracts to fulfill the user's request. For example, if the user asks to create a new document, Payload will generate an API contract to create a new document entity in the system. This contract will include events such as document created and storage entities like document metadata to store information about the new document. The API contract is then handed over to magicui, which handles the front-end and UI aspects of the system. Magicui uses its React and Tailwind-based UI components to render the response to the user. It also handles any necessary events, such as button clicks or text input, and sends them back to Payload for processing. This seamless handover of work between repositories enables the system to maintain a smooth data flow, ensuring that the user's request is fulfilled efficiently. Finally, coolify comes into play, handling the DevOps and deployment aspects of the system. Coolify's self-hostable and open-source nature allows it to manage the system's servers, applications, and databases on the user's own hardware. It ensures that all configurations and data are saved locally, giving the user full control over their system. By integrating with the other repositories, Coolify enables the system to deploy and manage the necessary services and applications to fulfill the user's request, making it a crucial part of the overall architecture. As the request is fulfilled, the user receives a response, and the system waits for the next voice request to start the process again. To bring this private voice assistant to life, we need to integrate the various components in a logical order. First, we'll start with the speech recognition capabilities using OmniVoice-Studio, which will allow us to process voice requests locally. Next, we'll incorporate Onyx, the self-hosted LLM platform, to provide a robust and private AI engine for our assistant. This will enable features like voice cloning, text-to-speech, and speech-to-text. Once we have the core speech and AI components in place, we can focus on building a user-friendly interface using magiciui's pre-built UI components. This will give our assistant a modern and intuitive look and feel. To manage the backend and database, we'll utilize Payload, a Next.js native CMS that can be easily integrated with our existing application. For local development, we'll use Coolify to set up a self-hosted deployment environment, allowing us to test and iterate on our assistant without relying on external services. We'll also implement background jobs to handle tasks like voice processing and AI model updates, ensuring that our assistant remains responsive and efficient. In terms of testing, we'll need to verify that our assistant can accurately process voice requests, respond correctly to user queries, and maintain user privacy and security. We can use pseudocode like voice request, text transcription, AI processing, response generation to outline the key interfaces and workflows. As we move towards production deployment, we'll use Coolify to manage our servers, applications, and databases on our own hardware, ensuring that we maintain full control over our users' data. We'll also need to implement robust security measures to protect user privacy and prevent unauthorized access to our assistant's capabilities. By following this practical build order and testing approach, we can create a fully private voice assistant that meets the needs of privacy-focused users. To bring this privacy-first voice assistant to life, start by cloning OmniVoice-Studio from source to ensure the latest features and fixes. Run git clone and install dependencies with npm install. For real-time performance, configure Onyx by setting up a local LLM provider like Ollama, specifying the model path in Onyx's environment variables. Use magiciui's pre-built components by importing them into your Next.js project with Payload, ensuring Tailwind CSS is properly configured for styling. Deploy the stack using Coolify. Set up a server via SSH, install Docker, and run Docker Compose up to orchestrate containers for each service. OmniVoice requires no API keys or cloud dependencies, but note it's in active beta, expect occasional breaks. Onyx demands manual setup for RAG or code execution features, while Payload's CMS needs database configuration even for the starter template. magicui components are ready to use but may require customization for perfect UI alignment. Coolify offers free self-hosting but needs at least one dedicated server for orchestration. All tools are open source. OmniVoice and Onyx use MIT licenses, Payload is MIT, magicui is MIT, and Coolify uses Apache 2.0. No costs for self-hosting, though Coolify's cloud version starts around $5 a month for managed infrastructure. A developer can today clone OmniVoice-Studio, navigate to its directory, and run npm start to launch the desktop app, ensuring all 646 languages and voice cloning tools are ready for local use. How would you integrate Onyx's voice mode with your existing privacy workflows for seamless local AI interactions?